Hello, today's video is on different slopes in the coordinate plane. So the coordinate plane, we have the coordinates are x and y. Remember, the first number listed is always the x. The second number listed will always be the y. So this is our first x, our first y. This is our second x and our second y. And in case you have forgotten, don't forget the slope formula to find the slope between any 2 points. You subtract the y's on top and you subtract the x's on the bottom. So the first thing we want to do is we want to find the slope of this given line. So we have the y's, 13 minus a negative 5, 4 minus a negative 2. We know those double negatives means that we add. So that gives us 18 over 6, which is going to be 3. So the slope of this given line is going to be 3. For parallel lines, remember, are lines that never intersect. And the way that those parallel lines work is they move in the same direction, the same distance apart. Therefore, their slopes are going to be the same as the given slope. So if this slope is 3, then this slope is 3. They have to have the exact same slopes in order for them to be parallel. Then we have perpendicular. Perpendicular has 2 properties. It has to be the opposite and reciprocal. And sometimes we look at one and we forget that they both have to be there. If they're just opposite, it's not perpendicular. If it's just reciprocal, it's not perpendicular. Now the opposite is referring to the positive negative. So since I started as a positive, the opposite of positive is negative. The reciprocal is when you flip the numerator and denominator. So I could make 3 into 3 over 1. So when I do the reciprocal of that, it becomes 1 over 3. So the perpendicular slope is going to be a negative 1/3. We're just going to do that same thing. So we start with finding the slope of the actual line we're given. So we subtract the y's on top, subtract the x's on the bottom. Now notice this double negative is not in the same place like our second one. So it's negative 7 minus 1, which is a negative 8. Here, minus a negative means that we're adding, giving us 16. And negative 8 over a positive 16 is we're going to reduce down to a negative 1/2. So the slope of this line is a negative 1/2. Parallel slope means it's exactly the same. I don't change anything. I just copy whatever I have here. Now perpendicular, we have to do the opposite. So I started with a negative, so it becomes a positive. I do the reciprocal of 1 over 2 becomes 2 over 1, which just gives me a positive 2 slope. Last one. Why don't you press pause and see if you can just find the slope correctly. So go ahead and press pause and do your slope formula. Find the slope between these 2 points. See how you did? We've got 12 minus 3, 16 minus 4. That should have left you with a 9 over 12. You want to make sure that you reduce that down. So if you got 3/4, you are good to go. All right, now press pause again and see if you can correctly identify the slope, parallel slope, and perpendicular slope. All right, so we have the slope 3/4. If it's parallel, it's exactly the same, also 3/4. Perpendicular, we started with a positive, so it became a negative. We flipped what was on top and bottom, so that becomes a negative 4/3. All right, so now let's look at the points on an actual grid. We have all of these points. It says using any method. So you could use the slope formula that we just talked about, or you can do rise over run. I'm assuming, I'm suggesting that you use rise over run. Go ahead and count, and you don't have to worry about subtracting a number wrong. We're just going to count to find each of the slopes. You could do whatever you want, but I'm going to count. Using proper geometric symbols. Notice how that is highlighted. Very important. State which lines are parallel and which ones are perpendicular. Then, we don't like this word, explain your reasoning for each. This is a test question. So this is another big question that you want to pay attention to. The first thing we want to do is find the slope between PQ. So we see P, we see Q. We're going to count our rise over our run. So as I count down, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I am going down 15, therefore it's a negative 15. 1, 2, 3, 4, 5. I'm going right 5, therefore it's a positive 5. So my slope is a negative 15 over 5, which is going to reduce down to a negative 3. The next one is asking me to find the slope of SR. So I find S, I find R. I'm going to count my rise over my run. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I'm going up 12, so it's a positive 12, right? 1, 2, 3, 4. I'm going right, so it's a positive 4. So we've got 12 over 4, which ends up being a positive 3. Next one, we got SQ. And you don't have to go from S to Q or Q to S. It doesn't matter. It's going to end up being the same answer in the end anyway. So if I go from Q to S, I'm going down 1, 2, 3. Ooh, down means negative, right? From here, we go 1, 2, 3, 4, 5, 6, 7, 8, 9. Right means a positive 9. So I've got a negative 3 over a positive 9, which gives me a negative 1/3. Moving on to our next set, we've got PR. Why don't you go ahead, press pause, and find the last two slopes on your own. All you've got to do is count. All right, check to see how you did. From P to R, I went down 6 and right 18, which is a negative over a positive, reducing down to a negative 1/3. For QR, I went up 9 and right 13. 9 over 13 does not reduce. So now what we have to do is we have to analyze this information, and we have to use this information to draw our conclusions. Remember, what we wanted to do is determine which lines were parallel and which ones were perpendicular. The parallel ones shouldn't be too hard to recognize because remember, parallel means they have exactly the same slope. So if I look through negative 3, positive 3, those are not parallel because this one is negative and this one is positive. But I look here and here. Those both are exactly a negative 1/3. So the first thing that I can conclude is that line SQ is parallel to line PR. And again, remember in the directions it said using proper geometric symbols. We have lines, so we use the line symbol. This is parallel, so we use the parallel geometric symbol. So when it says using proper geometric symbols, this is what I'm looking for. I know that those two lines are parallel. Now here comes the explain part. Because, and it's just, your explanation is how did you draw the conclusion? How did you know that that was what was going on? I know that those two lines are parallel because they have the same slope. And in this case, they have the same slope of negative 1/3. That's all you have to do when you're doing your explanation is how did you draw that conclusion? How did you know that they were parallel? We're not done though. Now we have to look at our perpendicular relationships, and this one can be a little bit more difficult. We have to think back to what does it mean to be perpendicular? And perpendicular, we said, has two properties. They have to be opposite and reciprocal. So if I were to look at this, the opposite of negative is a positive, reciprocal 1/3. I don't have anything that is a positive 1/3. I have negative 1/3. If I look here, opposite of positive is negative. The reciprocal of 3 is a negative 1/3. I have that. I have that here, and I have that there. That means that I have a couple different lines that are perpendicular to each other. I have that line SR is perpendicular to SQ, and line SR is perpendicular to PR. Because I am looking for a negative 1/3 slope, and those both have negative 1/3 slopes. I know that those lines are perpendicular because their slopes are opposite and reciprocal. Remember, it has to be both. If it's not both opposite and reciprocal, then it's not perpendicular. If it's just opposite, it doesn't work. If it's just perpendicular or reciprocal, it doesn't work. It has to be opposite and reciprocal. All right, and that was our last question for our notes today. Again, this last one is a big one. It is a test question, so make sure that you have notes written down for this one, and we are all done.